So for the external, you've got to do this bit on data encoding. I tried to do something with a bitmap in class, which didn't go to plan, and I'm just trying to recover that here by showing you what I kind of meant to do. So I'm in Microsoft Paint here, box standard Microsoft Paint, and I've just got the usual blank canvas. I'm just going to resize this canvas, and I'm going for 10 pixels by 10 pixels, which is a slightly fiddly mouse operation. I don't know if you can see down the bottom there we go, 10 pixels by 10 pixels it tells me. So white image at the moment is going to be useful if we can actually make that a red image would actually be really good. So I'm going to go over here and choose a color, but actually what I'm going to do is edit colors just to make sure I've got the right thing. So for example, this red that I've got here is perfect, but some of them might not be. So what you want is over here the red to be 255. So the whole point of this is we're showing how a bitmap stores each pixel using 3 bytes. 1 byte for red, 1 for green, 1 for blue. And in this case they go from 0 to 255 because that's 1 byte of 8 bits. And so this is maximum red, minimum green, minimum blue. And what also seems to work is saturation 240, luminosity 120. Not quite sure how that works out, but so long as you've got 25500 and set those to that, you should be all good. So that's my color now. I'm just going to use the paint bucket and fill that. So now I've got an entirely red image, and I'm going to save it. Save it as a bitmap. So saving it in this computer science folder, a 24-bit bitmap seems to work for me. So if I hit save, and let's, what did I save that as? Untitled.bitmap. That's a really bad name. Can do something better than that. So untitled.bitmap, size 374 bytes. Now if we think about it, we said that each pixel was 3 bytes. So we've got 10 by 10, we've got 100 pixels. So 100 times 3, that's 300 bytes for the pixels. And that is actually about right. The other 74 bytes are just that overhead stuff. Like in the header, there's information to say that this is a bitmap and what kind of encoding it is, 24-bit or 16 color or whatever. So that sounds about right. Now I've got this cunning thing installed on my USB drive. So I've got a USB drive here. I've got Foothead, which is a hex editor, and I'm running this directly off my USB drive. You'll be able to do this as well. So when I go to this hex editor, I can view the actual numbers on disk of untitled.bitmap. So I go into that folder, untitled.bitmap, open it up, and we can see exactly that. So you can see this top part here. This is that 74 bytes of header that I spoke about before, and then we've got FF0000, FF0000, FF0000. So this is the red, that's 255 in hexadecimal, green, blue, red, green, blue, red, green, blue. So each set of 3 numbers is 1 pixel stored in red, green, blue format. So if you're able to communicate that as part of your external report, then you've absolutely nailed that whole data encoding part. And the other thing that you'd be able to do then is say, okay, I've looked at bitmaps where we store them as 3 bytes per pixel, and then start talking about JPEGs where there's compression when you do the compression part of the this section. You won't want to compress this though. A flat small image actually doesn't demonstrate the compression artifacts that you want to show. And also, funnily enough, I've found that when you do try to compress something this size, it actually becomes bigger because of all the overhead describing what compression algorithm it's using and all kinds of other stuff. So you'd need to do that on a separate image. There you go, done.